Doing some basic statistical analysis to compare data collected in an experimental design. And so if you remember in class last week, we were scoring potato french fries using QDA analysis. And during this time we were using 15 centimeter line scale, or our approximation of it for the purposes of our class. And we collected some data, and for each of our treatments we did an experimental design. Each treatment was one incremental step from the next treatment. So for example, treatment 1, we cut the potato and we fried it. Treatment 2, we cut the potato, we rinsed it in water and we fried it. This is important to note because between each of these steps we really only changed one processing step, and this will come up as we're doing our discussion on statistics. Now, I first want to do in this video just talk about some basic statistics that we're going to do in terms of collecting a mean and standard deviation. But first I wanted to show you organizing data. So I took treatment 1, and because we were collecting treatment 1 all at one time, I put it in one set of data. And just to follow down, treatment 2 has its own set of data. But when we're doing this descriptive statistics, I am not comparing the score of color versus flavor within a treatment. I am comparing color between treatment 1 versus color between treatment 2. And so I need to make a second grouping of my data. This is all just the color scores, and all I did was copy. Now I'm not copying my mean, but I'm copying this data over. Now, we do need to start with our means. Do you remember we were talking about looking at the variance on the data and the standard, or the variance on the data and the means on the data. The mean shows where did it score, and the amount of variability or variance or standard deviation, if we can use that term, indicates how much that data is spread all over the place or how tightly it's packed together. So first I'm going to do my mean, and mean means that we're looking at the average bracket, and I'm going to bracket out all this. If the box is empty, it's not counted as 0 and it doesn't skew it, it's counted as a blank box. Whereas if I had 0 in there, it would be considered as a 0 and it would throw the number lower. Let me just type a 0 in there just to show you what happens. Oh, see? Leave your box blank. I can copy this across, and that will give me the means on all my data. Now if I just quickly said, well, which ones are the same, I might hypothetically say, oh, well, these are pretty close, and these are pretty close, they must be the same. Well, we can't exactly do it that way. If you remember, the variance on the data is going to help us indicate how tight or how spread out that data is. And so just for fun, let's add a standard deviation as well. STDV. So I'm going to pick that. Come on, ST. I'm going to do the same thing. Just bracket out the data. And this is just saying more or less how much is that data spread. I'm going to play around with it just to have a little bit of fun here. I'm going to bold those just to make it separate and different. What would happen if I suddenly had, instead of the number 8 here, 1? Think about how that's spreading your data out wide. 1. See what happens. Oh, see, my standard deviation just went up quite considerably. And so by having really widely spread data, your standard deviation expands out. Tightly grouped together data sets are going to have a small standard deviation. And that mean, again, is going to indicate to us where the average or the central tendency in this data lies. So those are some basic summary statistics. I'm going to do the same thing for flavor, potato flavor, and texture, and then I want to show you how to do some side-by-side comparison with these statistics.